Hey, this is Christina from Studio SE, and I'm going to show you how to set up a really simple Monte Carlo analysis using the CATIA Magic brand of products. So let's go ahead. I'm going to set up a package for this. I'm just going to call this my structure package. I'm not sure if you're familiar with Monte Carlo analyses, but they're really good to use to assess kind of like your overall process or product variation. So what I'm going to do, I'm going to include a couple of blocks. This is just going to be really, really simple. I'm going to set up a system and maybe component A and component B. And maybe we've done some analyses where we understand, what our variation is with component A. So we'll give that a real number. We also know component B. Maybe we've looked at like the history of manufacturing variability or whatever it might be to understand, our overall variation. So what we can do in CATIA Magic to show our variation within some of these variables is actually assign distribution to them. So what I'm going to do is open up the specification for each of them. And in the applied stereotype, I'm going to select, give it a normal distribution, and maybe, we've done some sort of analysis to understand what our variation is in these two value properties. So let's say that this one also has a normal distribution, and we'll choose the mean to be maybe 2 and 0.75 for this. And our system is composed of these two parts, so we'll give the system some part properties. And maybe we've done something where we understand, the relationship between A and B on the overall system variation. So let's go ahead and say that we have our calculation, and we've done a bunch of experiments, and we know that our total system variation is going to be A times B. So we're going to give our system this value property equal to T. That's going to be a real number. And then our system needs to have access to this equation, so we're going to give it a constraint property. Now, what I actually like to do when I'm doing Monte Carlo analyses is I actually set up an overarching, system analysis block. So I'm going to say that we're performing an analysis on this system. And then, for right now, let's just go ahead and set up the parametric diagram to make sure everything is calculating properly. So I'm going to set this up actually underneath the system analysis block and go ahead. We're going to access all of these. Oops, what I did not do is give this parameters. So let's go ahead and do those parameters, and we can go back over here and display this. So now we can, now we're going to have access to all of those parameters, our distributed properties, etc. So let's go ahead and set this up. I'm just going to move some things around a little bit for space. We have A and B over here. T is going to be over here. And we're going to bind these together. Okay, and let's go ahead and just run this to make sure everything is executing properly. So we see that our component A, we're pulling in a value from that distribution. Same with component B. It's all mapping properly to our parameters. And then our value of T here is being tied to our system's value property there. So that's all checking out. So that's good. Now, what we can do to actually set up the Monte Carlo, and the beauty of Monte Carlo is that, you're not just running it one time. You can run this 100, 250, 500, 1,000 times to understand what is this overarching variation, what's it going to look like when I'm executing this a number of times. So I've done a lot of Monte Carlo analyses to understand, things back when I was in the cell therapy industry to understand, how many files are we getting, how much drug product are we getting, given all of this process variation. So what we can do actually to set this up is CATIA in our auxiliary resources. We have access to this Monte Carlo analysis block. So let's bring that Monte Carlo analysis block on here. And we're going to say that our system analysis block is going to inherit the properties from this Monte Carlo analysis block. So let's go ahead. Let's hide that. And then what we can do in our parametric diagram is we can elect to display those properties now that we're inheriting from that Monte Carlo analysis block. So let's go ahead and right now I'm just going to display the mean. I'm not going to do anything with the out of spec. I think the out of spec is kind of weird with this, to be quite honest. So now we want to say that our t, this is going to be tied to our mean. And so something that's actually powerful now is we can create a requirement on our mean saying like our mean needs to be maybe less than or equal to something. So let's go ahead and create another package for requirements. We'll create a requirement diagram on here. And we're just going to say, and this is going to be our requirement on average, and we're going to say the average of this process variation shall be less than or equal to, I'm trying to, 6.2, I think is going to be a good number for this. And then what we can actually do is we can extract a constraint block from this requirement. So let's put that here. So now we see x is less than or equal to 6.2. And we actually want our system analysis block to access this constraint property here. So now what we can do is go back to our parametric diagram and we can elect to display this constraint property, display its parameter. And now we're putting this requirement on the mean saying that our mean now needs to be less than or equal to 6.2. Let's go ahead, let's run this again just to see what this looks like. I'm not sure. Okay, here we go. So now we're seeing that when we run this, again, we're running this off of, one run. So we're pulling one number from A and one number from B, and we're assessing this one time. So here we're seeing that our mean is 4.772. That's less than 6.2, so we're passing that requirement. That's awesome. Now again, the power with Monte Carlo is we can run this a bunch of different times to understand this overall, process or product variation. So what we're actually going to do, the first thing I'm going to do is I'm going to create a package to display like a result table. So let me create an instance table here. And our classifier is going to be our system analysis. I'm going to store all of our results from our simulation within this results package. So I'm setting that scope here. I'm just going to elect, I don't want to display that. Sure, we can display deviation. Let's also display this T here just to show still, where'd that go? That our T is being tied to our mean. So I'm just going to drag that over here. Okay. So now I'm going to create a new package to run the simulation itself. And we'll create a simulation configuration diagram on here. So I'm going to set the simulation configuration, the execution target. It's going to be executing on the system analysis block because that's where I'm running all of my parametrics, and it has the Monte Carlo and all that sort of stuff. It's going to call this Monte Carlo analysis for system. And I actually want to display a histogram just to see the overall variation. So I'm just going to do a histogram on the value of T. And I'm going to say that this is going to represent our system block because that's the block that owns the value that I want to display. So I need to tell it what actual value I want it to display. That's going to be T. I'm going to keep this open after termination. And I like to just see things, seeing the histogram run as we're populating or running our however number of runs we're doing. Okay, so then I'm going to add that to our Monte Carlo analysis configuration. And then in here, right now, number of runs, we don't want this to run once. I want this to do, let's for fun, let's do 500 or something like that. And then every time I run this analysis, I want it to display the results in that folder that I created. So we're going to select that folder. And I think that should be fine for this analysis. So let's go ahead and run this. Let's do that. And so my histogram was populating on another window, but I can see here, here's the histogram of this value of t. We ran it 500 times. That's the mean, the standard deviation. We haven't actually tied anything to out of spec, so that's fine. Now let's go ahead and look. So in our containment tree, we see that we populated that instance that we ran this in that result location. And we have stored the values here. So actually, since I think we can do enable patterns-based verification on this, sometimes this is a little wonky. Is that going? Okay, so here we see that this is actually highlighting in red because the mean is greater than that 6.2 that we set for that requirement. So we're seeing that we failed that. Now we can run this Monte Carlo and now, oops, I just did another new here. We'll do another run like that. So we're populating our table every time we are running this analysis. We're passing all of these because it's less than 6.2. Let's just see if we can get one to fail. Might have to change some numbers around. Maybe not. But you can see we can run this any sort of number of times and we're populating our analysis or our results within this table. So this is kind of a cool example of how we can set things up in CATIA Magic. I've done Monte Carlos in Excel, in MATLAB, I believe. In CATIA, there's pros and cons to all of those different tools for running Monte Carlos. I do like CATIA because you can just kind of save the history of what you've done. But CATIA works really well for, more simple. It starts to take a long time to run with the more variation we add in our model. Hopefully this was helpful for you. I'd love to know, when you might want to do this in CATIA versus when you do it in MATLAB, what are your use cases for Monte Carlos, etc. But there you have that, and thanks for tuning in.